Hi everyone, I am Tiffany Curlew. I'm a quality control technician at the Jamaica Business Development Corporation and also a STEM ambassador for the Scientific Research Council.
And I'm Dr. Shade Foster, also a STEM ambassador and the team leader for the Natural Products Unit at the Scientific Research Council.
Welcome back to another exciting episode of our STEM Virtual Experiment series. We're so excited to be here. I see you holding a purple cabbage in your hand. What are we going to do with it today? Eat it?
No. No, we are actually going to conduct an experiment to show how pH affects the color of cabbage juice.
And what exactly do you mean by pH?
Well, have you ever tasted something like lemon juice that is so sour? Or have you ever tasted something that's bitter? This is because of something called pH. pH is a measure of how acidic or basic a substance is based on the concentration of hydrogen ion that's present. Let's take a look on the pH scale. So the pH scale ranges from 0 to 14, where 7 is neutral for like water. So if you should move down the pH scale towards 0, these substances are more acidic. And if you should move up the pH scale towards 14, these substances are more basic, like bleach.
Oh, exciting. And we'll be using purple cabbage as an indicator. And indicators change in response to changes in the conditions around them, such as a change in pH.
Exactly. So in our pH indicator experiment, we will be testing the pH of different substances using our purple cabbage juice.
Wow, that really makes sense because purple cabbage contains a pigment called anthocyanins. And anthocyanins change in color depending on the pH of the substance added to them. Anthocyanins can also be found in grapes, grapefruits, cornflowers, and even poppies. So, when you look on the purple cabbage indicator scale, for substances that are more acidic, such as lemonade or lemons, they would have a pH of 2. So when purple cabbage indicator is added, the color change would be red. And for substances that are more basic, such as baking soda, when purple cabbage indicator is added, the substance color will change to either green or yellow. So therefore, pH can be told based on purple cabbage indicator.
That's right. Now, remember earlier I said that pH is a measure of how acidic or basic a substance is based on the concentration of hydrogen ions present. Well, the more acidic a substance is, the more hydrogen ion it would contain. And the more basic a substance is, the less hydrogen ion it would contain.
Exactly so. I can't wait to see what's going to happen.
This is going to be so much fun.
Absolutely. We're going to have a blast.
Yes, let's go to the lab.
Since we'll be working with acids and bases, we'll be wearing our protective gear to protect us from the corrosiveness of these substances.
That's right. So we are wearing our gloves to protect our hands and our lab coats to protect our clothes and our bodies. All right, come on, Tiffany. All right, so today we will first start by cutting our cabbage into small pieces and putting some of this in boiling water.
Now be very careful when you're cutting the cabbage.
So we have about 500 mils of water boiling, and to that we're going to add about 2 cups of cabbage. Measure out our cabbage.
All
Right,
right.
so now we're going to leave that for about 10 minutes to soak.
While we move on to sort out the substances that we're going to be using to find this pH of.
So we're now going to prepare the substances that we want to test their pH. All right, so we're going to start with our lime juice. And for that, we're going to measure out 40 mils of lime juice. And now we're going to place that into our labeled container. Alright, so next we will measure out our carbonated beverage. I wonder what color this will change to.
Exciting.
Here's your beaker, your measuring cylinder. And remember, when you're reading the measuring cylinder, you want to read it at eye level. So Tiffany, what color do you think our distilled water will change to?
I don't want to give away the answer as yet. I want it to be a surprise.
So we're going to use 40 ml of distilled water as well. We're going to pour that in our container. Alright, so the next ingredient that substance we're going to test is our baking soda. And this is solid.
Right.
So we are going to have to dissolve that in water. So I've weighed out 40 ml of water. You can pour it in the container here. And to that, we're going to add 1 tablespoon of baking soda. Now we're going to mix it to dissolve it in the water. And move on to our next test subject, which is our household ammonia. And again, we're going to use 40 ml of that. And our final test substance is sodium hydroxide, also known as lye. So this again is a solid substance, so we will have to dissolve it in water. And I've weighed out 40 ml of water, and we're going to add half teaspoon, that's right?
Right, half teaspoon.
To it. Okay. Almost ready for the fun part.
Because it's solid, we have to stir to ensure that it dissolves. All right.
So Tiffany, what else do you think we need?
Well, the most important thing, our cabbage juice.
Yes, that's right. So now we're going to strain our cabbage water and collect the juice. So to each of our test substances, we will be adding 10 ml of cabbage juice. So let's measure 10 ml of our cabbage juice to add to each of our ingredients or test substances. Can you measure this one? Too much there. Just a little tips. There we go. And we pour it into our beakers. So we can have more fun. Teamwork make the dreams work.
Yes. And we have more fun when we work as a team.
That's right.
All right.
Workstation. Okay, Tiffany, the magic is about to start.
Oof, I'm so excited. All right, so we have all our 10 ml of cabbage juice poured out. So, Dr. Foster, let's start with lemon juice. Let's make a bet. What color do you think it's going to change to?
Well, I know that the lemon juice is acidic, so I think it will change to maybe pink or red, depending on how many hydrogen ion is present in it.
All right, let's see.
Whoa.
Wow! All right, you won that bet. It really looks red.
So you remember that cabbage indicator scale that we had?
Yes.
And red was for a pH of around 2.
Correct.
Yeah. All right, so next we're going to
move on to our carbonated beverage.
Right.
Woo! Okay, this is pink.
So what does that mean? Which one is more acidic?
Well, of course the lemon juice would be more acidic. So I'm guessing lemon juice would be around pH 2 and carbonated beverage would be around pH 3
Or
4.
Right.
All right.
All right, so what about our
Distilled water.
Will there be any magic with that one?
Well, we know that water is neutral. So,
A pH of around 7.
right. So I think a slight purple violet color would be it.
Okay. we're
Good.
right.
Yes. Perfect. And now our baking soda.
So our baking soda has a pH of which is higher than 7. So it's now on the going towards the basic side of things.
Right. So I guess the colors. Let's see. I'm thinking baking soda would be blue. Let's see. Wow. That's a nice shade of blue. All right, now we're on to our household ammonia. Still on the basic side of the scale. So let's see. Wow.
Green color.
That's really green though.
Yeah.
And last but not least,
We have our sodium hydroxide or
Right.
a lye solution.
last bit. What do you think?
Yeah, yellow.
Yellow? I agree. Ooh.
So it's not yellow, it's more of a green color. But
Greenish.
will it change as we mix? Notice it's getting
Getting more
lighter
dark.
and lighter. Give you a lighter color green. Right. So
Let's
you get a
see.
light
Right,
green.
it's like a greenish yellowish color.
So what would change it to a yellow color?
More sodium hydroxide. Oh,
It's
look.
looking more yellow. See the color change over time as the reaction continues.
Nice.
So we're correct.
Perfect.
Right, so there we go. So we were able to demonstrate that our cabbage juice can be used as a pH indicator, and the concentration of hydrogen that is present in the solution will also give an indication of the pH based on the color change that we see. So just as the scale that we showed
Yep.
earlier, the lemon juice
Be more acidic.
being acidic gives us a red color change when the cabbage juice is added to it.
Right. And of course, our sodium hydroxide, being more basic, gave us the yellow color.
That's
Right. Do you know what would be really fun, Dr. Foster?
What's that?
Making an at-home pH strip.
That's something that we will be doing today.
Great.
So all you would need is filter paper and of course our main ingredient, or cabbage juice or cabbage water.
Perfect.
Right? So you take your filter paper and we're going to pour some on it so that it's completely soaked.
Nice.
All right? So now we're going to put this aside, hang it up somewhere and allow it to dry, and then we'll get back into the lab.
All right, great.
All right, so here we have our filter paper that is completely dried. So now we're going to cut it into strips. Do you want to cut it into strips?
All right. All right.
Right,
Great.
so now we're going to check the pH of our substances. So we have poured out some new set, and we are going to see if we observe similar color change. Now we're going to start with our lemon juice, right?
Right.
And we already know that we're expecting a red color change. So put a drop,
Wow.
and there you go. So we know that the lemon juice is, if we compare it to the cabbage indicator scale, has a pH of around 2.
Perfect.
Right?
Mm-hmm.
So next,
Move on.
move on to our carbonated beverage or soda. And I'll add a few drops. And you get more of a pink color.
Right, a light pink color.
Light pink. Right?
Mm-hmm.
Next will be your water. And we expect it to give us a purple color. It remain purple because water has a pH of around 7, which is neutral.
Yeah, perfect.
Then we add our baking soda, which is more on the basic side of the scale. And we're expecting a
Look at that blue
color change. So
really nice.
Then our household ammonia. And we expect to see a green color
Nice
change.
green. Wow.
There we are. So this pH.
And last but not least, our lye.
Lye solution. And you remember what happened the last time we added lye?
Right. So the last time we added, it took a bit of a time before it changed to yellow.
Right. So we got like a
green
color, and then
it changed.
It changed to yellow.
Right.
So let's see if the same thing will happen here.
All right. So we're seeing the green.
Mm-hmm.
There, look, it's changing.
Yeah. So it's looking more of a yellowish green color now.
Which what we were expecting.
Yeah. So there we go. We're able to use our cabbage juice to test regular household items, the pH of those substances. It was so much fun in the lab today. How do you feel about it?
It was great, Dr. Foster. I had lots of fun.
Yeah, especially learning about pH and about acids and bases.
Yes, and even the anthocyanin pigment in red cabbage. Wow, such a magnificent thing
Not
to
to
see.
mention the brilliant color change we saw when we
So
add our
good.
cabbage juice to our test solution. And these are all household items.
Yes, yes.
Right? But an alternative we showed where you could create a pH indicator, pH strips,
Yes.
by soaking the filter paper, or you could use coffee filter as well.
Yes.
Yeah, soaking it in the cabbage juice and allow it to dry, and then we could add a little bit of our household solution to it and observe for those beautiful color changes.
Nice, nice. That sounds really good. So, don't forget to like, share, and subscribe. And see you on the next one.
See ya! So, Tiffany, what else do you think we can
Let's
do?
think about bleach.
Maybe we could check, bleach or even vinegar. Let's
Yes,
go.
let's go.